We have a pretty packed day and a pretty packed agenda. So we have a morning with welcome and introduction, and then we're going to go through several presentations on the impact of electricity grid tariffs, on blockchain technology, on data value creation for city stakeholders through blockchain. We will have a short coffee break, and I'm kind of conscious of the time, so maybe I will shorten it a tiny bit, where afterwards we will go through a second series of presentations, and also go through pitch sessions and interactive sessions. Now, I'm not going to take up any more of your time anymore, so I would like to welcome all of you to the hybrid workshop organized by Sparks and Positive Horizon 2020 project. And take a seat, those of you who are at homes. Those of you who are in Brno, please also get yourself comfortable. We have Francesco and Jose Miguel from the two projects, Sparks and Positive, who are also online, that will be also helpful in answering your questions. And I'm now going to give the word to Anne Sully, who's a member of the Mission Board on Climate Neutral and Smart Cities, to kind of welcome you and give a short overall introduction to the topics that we are going to be discussing today. Welcome, Anne, and welcome everybody.
Thank you very much, and welcome everyone. I've been asked by the organizers to share with you some of the work that has been done in the course of the last year on the mission on smart climate neutral cities. And as said, I am one of the 15 board members of the mission. I think it's important to emphasize first that we do not yet have a mission. It's rather a mission proposal that I can talk about, that we hope that eventually will be approved by the Commission and the member states. And even that one is in a draft form yet, so it can change along the way. The idea or the aim set by the Commission is to help transform 100 cities in the EU to become climate neutral by 2030. The mission's role is to create a supporting framework for this to happen. So the cities that are chosen are to act as innovation hubs to other European cities to share their experiences and cooperate with everyone in the EU. The background for the mission comes from the works of Mariana Mazzucato, who is an economist who has done extensive research into the relationship between innovation and economic growth. And she has observed that a lot of innovation spillovers had come from the American moonshot mission when the US government set aside considerable resources to put the man on the moon. The idea of the mission is similarly to set a challenging goal, provide the necessary financing and preconditions, and expect this to lead to innovative solutions along the way, thereby boosting European competitiveness alongside achieving the climate neutrality goals. So when we started a debate about the mission, there was discussion about whether to take a holistic approach for climate neutrality in cities or set a narrower focus, but the majority supported the idea of a holistic approach. So cities who want to participate need to have a plan for bringing Scope 1 and Scope 2 emissions down to zero. There will be some room for offsets, but it remains to be regulated what type and to what extent would be acceptable. The holistic approach will obviously be very challenging, especially from the point of view of financing. The estimated budget totals close to 100 billion euros. And a more delicate challenge is to find ways to mobilize financing in towns of less wealthy member states. Citizens' engagement is one of the most important aspects of the mission because achieving climate neutrality will require, besides technological innovations, also behavioral change among people. So citizens' engagement has been one of the most talked about aspects of the mission during our meetings. In terms of selection criteria, given the diversity of European cities, the mission board was of the opinion that the mission should be as inclusive as possible, leaving no one behind and taking into account the differences in European cities and their preparedness to act. So there will be beginners, experienced, and frontrunner cities. The same evaluation criteria will apply to all, but different thresholds will be applied depending on the city's preparedness level. The most important thing that cities need to have is a good and ambitious strategy for climate neutrality. They need to have engaged stakeholders and citizens. They need to prove that they are capable of living up to their promises, and they also need to demonstrate their track record in the field. When discussing the selection criteria, we had lengthy debates about the way to set up competition among cities. We realized that by definition, cities in wealthier member states will be better positioned in terms of competition, because if you have more means, you obviously can afford to be more ambitious. So we decided to propose to aim for at least 3 cities per member state where possible to have inclusivity across Europe. We also had lengthy debates about the size of the cities that would be able to participate. The Commission suggested we use the definition of OECD, for which a city has 50,000 inhabitants or above. But then we realized that in many small member states, there will be very little, if no competition, if we set that level. So we compromised at a formulation that if a member state has less than 5 cities with a population above 50,000, then we will drop the bar to 10,000 for them. We also realized that achieving full climate neutrality in large cities might be an insurmountable financial challenge in such a short time scale. So we compromised on the possibility that it will be possible for city districts who have their own government to apply for the mission in case this entire city needs more time than 2030. Now, the application process is divided into different phases. In the initial phase, cities undergo an eligibility check. In the next phase, they need to prepare a full application for a climate city contract in co-creation with citizens and stakeholders. If the application is successful, then the next phase is to develop the climate city contract, which would be a binding document covering all the ingredients of the mission, and it would be signed by the mayor, the commission, and by respective national authorities. What's important to note is that applicants will also receive support from the Commission in phase 2 when developing their final climate strategy and financing plan. Financing on the EU side will be organized in a coordinated manner so that cities wouldn't have to apply to each different program separately, but there will be one application for the entire financing strategy. So these are some of the highlights that I wanted to share with you. If you want to learn more about the city's mission, you can find a draft of the report on the Commission's website. You just have to search Mission 100 Climate Neutral Cities by 2030. But as I mentioned, this report is not yet final nor complete, so we continue working on it, and we hope to have it in a shape to be communicated more widely by the end of the year. So that's it on my part. I see you have a very interesting agenda for today, which is very relevant also for the city's mission. So I wish you a good day and good luck with your projects. Thank you.
Thank you very much, Anne. Thank you. We will go shortly to kind of the next speaker, because the program is really packed, but please do stay with us and listen to what all our presenters have to say. I would like to welcome now Dorian Frieden and Anna Eisner, who are actually on site in Brno, and they're going to speak about the impact of local electricity grid tariffs for energy communities. Dorian, the floor is yours.
Yes, hello, I hope you can hear us. And see the slides also. I think it works, yeah. So hello everybody, we are actually sharing the presentation. We are both from Joanneum Research in Graz, Austria, which is the second largest non-university research institution in Austria. And we'll speak about local electricity tariffs for renewable energy communities. and potential impacts on energy cost savings, in particular for vulnerable consumer groups, with the example of Vienna. So I'll just give a brief input on the policy context, on the questions driving our analysis. Anna will present the results, and we'll end with some open questions and conclusions. So what is it all about? I guess some of you are not fully convenient with the concept of energy communities. We have now the clean energy package in place, the new one on European Union level, where energy communities are defined. We will focus here on renewable energy communities, which are part of the Renewable Energy Directive 2, Article 22. And just very roughly, this is primarily about generation, sharing, storage, and sale of renewable energy. These are groups that can be formed within a legal body to do these kind of activities and have a local character. So there will be renewable energy projects in a local area. So several member states are now developing local grid tariffs, aiming at cost reflectiveness of the tariff system, which is based on electricity sharing actually in the area by using the public grid. So that's something that's very new, that you can share with neighbors electricity using the public grid. And for this, these tariffs are discussed. Yeah, one thing is very central here, that vulnerable groups should be targeted by these concepts as well. And that's why we are asking these questions on potential impacts. In Austria, there's a renewable expansion law coming very soon, which will include a concept on local tariffs, also having a supportive character. We'll speak about that more. So the questions driving our analysis are: how much can vulnerable groups save by being part of energy communities? What does a potential local tariff contribute to that? And how does this relate to income of these groups and other potential savings through, for example, direct consumption within a building and reduced electricity costs? And I will now hand over to Anna Eisner to actually present the results.
So, hello everyone. First of all, we have some assumptions for our analysis. These assumptions are about the households, the photovoltaic electricity that is produced within the community, and of course the tariffs. For the households, we use information of the Austrian EU Silk survey of 2018 for Vienna. We look at different household types. These are, first of all, an average Viennese consumer. Second one, we look at risk of poverty consumers. And also, finally, we look at materially deprived consumers. These consumer types differ in their electricity consumption per year, in the costs they are having for electricity, and of course in income. For the photovoltaic electricity within the community, we assume generation costs of 6 cents per kilowatt hour. And for the tariff, we use an average electricity tariff in Vienna, which has overall costs of 21.33 cents per kilowatt hour, whereof 7.7 cents are the energy price. For the scenarios, there are 3 different things we have to consider. First of all, that there is the tariff reduction Dorian already told us. In the chart on the right, you can see the different components of the electricity price in Austria. And for the tariff reduction, we have 3 different parts that might be reduced for the consumers. So first of all, there might be a reduction of the consumption-based cost component of the grid tariff, which can be seen here in this part of the pie chart. Then second, the members of an energy community will not pay, or are considered not to pay renewable and electricity surcharges for the electricity that is shared within the community. And finally, they will also not pay a VAT for the electricity within the community. The second point is how much electricity is shared within the community. Here we have scenarios from 10 to 40% of the total electricity consumed per year. And the last question we also ask is, what impact has direct consumption on the costs? And here we have scenarios with and without direct consumption. And we do not assume a direct consumption which is higher than 30%. So our first scenario set is without direct consumption. So first we look at the case without direct consumption. You can see on the left chart, here are the potential savings for the different household types, where the potential savings are only generated by reduced energy costs. So you generate your savings by the difference between the costs of the electricity within the community and the price you would pay from the grid provider. In the last scenario here, where we have 40% of electricity that is consumed from the community, the potential savings are rather small, with only 2.25 euro per month. But when we also include a tariff reduction of 70% of the grid tariff, the potential savings are increasing to 13.91 euro per month. So we can see that the tariff reduction largely exceeds the potential savings from the reduced energy costs. So, and as a last point, we look at the direct consumption. So how can the potential savings be increased when we also have direct consumption for the households? In this case here, in the last part of the graph, we assumed a direct consumption of 30%. And it can be seen that the potential savings are increasing from around 14 euro to nearly 26 euros per month. Here we can see how the different price components affect the savings of the households, and it can be seen that direct consumption has the highest impact, followed by the tariff reduction, and the reduced energy costs alone have only a very marginal impact on the savings for household groups. But now this is the important part, which answers the questions we had at the beginning. What is the impact for vulnerable household groups? Because when we think on spendings for electricity, it has to be considered how much financial burden has a household by consuming electricity. So when we compare an average consumer in Vienna, which only spends under 2% of its income for electricity, and an at-risk at poverty household, which spends more than 5% of its income for electricity, it is necessary to use some reductions or some benefits from the energy community that benefits the poorer households. So when we only have reduced energy costs, the reduction of the expenditure share for the poor households is only small and is between 0.04% and 0.16%. But when we also include a tariff reduction, it is possible that poor households decrease their their expenditure share to 1%. So tariff reduction may have a more noticeable effect. And in this scenario, these reductions can lead to savings of over 166 euros per year for this kind of households, which is lots of money for these people. This is not only a decrease of the expenditure share of over 1%, this is also a decrease of over 20% of the previous electricity expenses.
Thank you, Anna. So I'll come to some quick conclusions. So what we've seen is that local tariffs that go beyond the grid element, because from the tariff savings, the grid element was only a smaller fraction, and the reduction of other charges was a bit more important. So going beyond simple grid reductions can be an important policy measure to support vulnerable households. We've seen that local tariffs may be important specifically for vulnerable groups because direct consumption may be less likely for these consumers. So you have direct consumption only if you have generation in your own building. And that is maybe less likely due to the needed investments for vulnerable households than for other households. So the local tariffs may be even more important here. However, given the importance of direct consumption that we've seen, for which you don't see any grid fees and other at all, could decrease the expenditure share of households importantly. So from the 5% Anna was showing to 3%, so a 2% reduction rather than a 1% reduction, leading to 4% of the income. So facilitating direct consumption would be very interesting and important to support as well for vulnerable groups. Just some open questions. So one of the questions really is how likely it is that direct consumption will be enabled for vulnerable groups. And I think in the context of smart cities, this is an important question as well in terms of settlement structures and so on. So if you have houses in which different social groups are living together and some people can afford investments and others may benefit that cannot afford it, this would be could be very helpful in this context, rather than having strict separation, so to speak, in terms of living areas. Another question is, what would be the conditions for vulnerable groups to participate in energy communities? Energy communities, as I said, are legal bodies. They may be carried out as cooperatives, for example. So if you have to buy a cooperative share, first of all, and then you have to invest in renewables generation, the entrance barriers are very high, of course, for poor people. So there are rules to be found to involve poor people as well, or vulnerable groups as well, including, for example, electricity for free, also for non-members, which is the case in Greece, for example, which is foreseen explicitly in the legal context. So targeted instruments may be required and may be very important to reduce the entrance barriers and to allow cost decreases for vulnerable groups. Thank you very much, and we are looking forward to questions, if there are any.
Thank you very much, Dorian. And for those of you who have joined a bit later, I'm going to remind you that you can post questions, either ask them directly if you're a speaker, or you can post them into the questions and answers box. I dare to say we have time for 1 or 2 questions, but please do feel free to post them, and then we will try to also answer them afterwards, if there's any questions.
Monica, you hear me? Francesco jumping in. Hello? You hear me? Hi. Oh, Francesco jumping in. Just I've got a question, if I may. First, a bit of background. So the event is about P2P platform, but when we were shaping the agenda, we thought of having this presentation to give us a bit the regulatory background that we are going to work on. And specifically, my question is how the P2P energy platform, in your view, can support this energy democracy? Specifically, when you talk about energy community, because you may think energy community basically lies on the renewable directive, the one that Dorian and Anne has presented now, and then on the electricity market directive. Well, now, when it comes to electricity market, it might be a bit more direct and intuitive, the link with the P2P energy platform. But when it comes to the renewable energy directive, what do you think will be the role of the P2P platform to, again, enhance and improve the energy democracy?
Well, if the question goes to us, well, peer-to-peer approaches are maybe very important in the context of energy communities. I mean, there's trading, for example, also foreseen in these concepts. And well, everything that brings together consumers, if you will, and participants is of major importance, of course, and may also provide some ground for exactly establishing the rules I was mentioning. So establishing mechanisms to involve vulnerable groups, think about how electricity can be shared and so on, going beyond, for example, what's often developed now, blockchain trade, or establish specific rules in this context. We'll hear about blockchains later, I've seen. So there is certainly an important link in terms of organizing, in terms of establishing rules for sharing and trading and these kind of questions.
Francesca,
I
for
hope
the
that answers the question.
And thank you, Dorian, for answering. I would invite you to then continue the discussion in parallel, because we have to move on a bit with the time. And so I'm going to welcome Simon Johanning from the Leipzig University to talk about actually blockchain technology. Simon?
Yes, thank you.
The floor is yours.
Thank you very much. I'm just going to share my screen. Okay, well, thank you very much for the introduction. I'm here to talk about the mystification of blockchain technology and the design decisions that are made in peer-to-peer blockchain-based electricity trade. And I got interested in it because I got curious when I looked at all the use cases that I saw, about the technical choices that are made. And I first want to start with talking about use cases in energy and applies to smart city as well in a more abstract. Do you hear me? Well, okay, good. Sorry. And what I realized that like the use cases are usually conceptually based upon one another. So you have peer-to-peer electricity trade and might be based on certification and tokens, and then based on smart contracts, on Ethereum, on document timestamping, crypt and hashing. So it's basically a stack of different use cases upon one another. And all these use cases are based on certain technical assumption. And as much as the use cases are based upon one another, the assumptions are as well. But when projects adopt this blockchain technology in a way, then they usually just take the assumptions wholesale and they don't question them. And the aim of my presentation is to present and to critically question some of the assumptions that are usually implicitly given, and to discuss how they are justified in energy and smart city use cases. And I want to start with the assumption that there's a global interest in transactions. So basically, that every user is interested in all transactions that happen in the entire blockchain. So basically, I'm interested in somebody buying a cookie in Brno, and Bitcoin is really not very useful for buying cookies, and most other blockchains either. And so the same question is, why should a presumer need to know who fed how much power into the grid at what time globally? But it's something that a lot of use cases assume, or pretty much all use cases do. Another one is that you cannot trust anyone. And there's an extraordinary effort that are taken to rule out the need for trust. But the cost of abuse are very, very high. Nobody's going to fork a blockchain just to revert the transaction for a chocolate bar or a kilowatt hour of energy. Furthermore, the energy sector is highly regulatory and institutional. And so at most, you could have a decentralized or a federated solution. And you just have to act to trust some of the actors. Furthermore, entities are often assumed to be anonymous. So like nodes, addresses, and user, nobody can be identified. But blockchain could just as well use trusted blocks and transactions that only have like some verified nodes, for example, send off. And it's possible to link entities and keys. But this is a choice that is has to be taken. That is a matter of protocol, but it's something that is usually just adopted wholesale, that you have to have a blockchain where everybody is anonymous, which just doesn't really can work for energy use cases usually. Also, often blockchain is the panacea to make all the data trustable, but with everything else, garbage in, garbage out. And transaction really only proves that data has been committed at a certain time and that somebody witnessed the data in its current form. Another one is a bit of a tricky one is the availability, and it's tricky because the discourse mixes availability and resilience. And blockchain is much more resilient than other architectures because all nodes that verify and that mine have to fail in order for it to not function anymore. But blockchain is not highly available and often is used the same interchangeably. Because not all the transactions are present, like the pending transactions are, for example, and it's like the consensus is not exactly consensus at a given time. There's always something worth not available. So it's kind of like comparing different types of fruits. And so blockchain is resilient, but it's not highly available, and that's something that the discourse should be a little more conscious about. Also, transactions are time critical is something that is usually said, and this is the reason. The question is, why is Bitcoin mining so extremely hard? to be certain that a certain transaction can't be reverted. So you have to, in theory, you have to wait an hour until you can like give the chocolate bar to somebody who bought it in order to be sure that they're not going to take back the money. But we're talking about contractual situations where there's a legal reversibility if part is identified. And so that's not time-critical transactions. And if you talk about energy community or peer-to-peer trade, when you have a billing period, at the end of the billing period, that's where it's critical, not at the time where it's fed in. Another one is the contract status of smart contracts, and the assumption is that it's equivalent to legal contract, and so that means there's context-specific intention, it's contestable, there's appropriate consideration, the terms and concepts are clear, but you cannot automize that. It's too soft to human. It's not, a smart contract can't do that. And as an example, there's ambiguity of terms. So you have, when you define a house, it could be real estate, it could be a dollhouse, it could be a noble family. These are legal terms that are discussed. You cannot automate all of that, but it's often assumed in many use cases. Furthermore, it's assumed that all transactions must go in the chain, but blockchain is not a performant database. And if you put quarterly, hourly, or even second granularity data into it, then it really grows and it's huge and costs a lot. And you have big graveyards of data and growing chains. And maybe it makes more sense to only save essential transactions. Yet again, it's something that's very rarely discussed. Another one is there's the horizontal and vertical completeness. So it's basically you have to have the entire world in one blockchain to rule them all. But maybe regional blockchains are something that you should think about, or to have really specialized chains that interact in a way, something like the Linux ecosystem. And finally, an assumption that I want to talk about is users as risk takers. And users are very easily overestimated. The user is not as digitally literate as we often assume, and they are very risk averse. And most users really do not want to handle key handling, for example, password recovery, and that kind of stuff. That is something which a lot of people don't really like to engage in. So these are the assumptions that I wanted to present. What are the consequences for the energy sector and just as well for smart cities? And to my mind, one of the consequences is that we should have a fundamental discussion before we talk about disruptive application, especially if we have the disruptive application because it's hip or popular or something. So we should think about data, about the properties of the use case, about the customers, about the actors that are involved in it, other entities, about the needs for that use case and for the actors within the use case, and what kind of trust we need. And only when we have thorough discussions about all of that, then we can think about what technology and what applications we really want to engage in. And it needs a differentiated analysis for each different use case. Another thing is that we should entangle automation and blockchain. So think about what is essential with regards to automation, and what is essential with regards to blockchain, and what value propositions really are covered by blockchain or by digital technology in more general. And do we really need blockchain, or what kind of blockchain do we need? Or do we just need some kind of automation or digitalization? Another question we need to ask ourselves is the question of governance. So we need to think about how fundamentally blockchain is appropriate for a solution. How much implicit anarchy do we want? Do you want to put all the responsibility on one user? And the question of self-determination versus organizational challenge, because it's really hard to organize all of that if it's really extremely distributed and we put all the powers to the users. So we should think about, do we want a federated or free-for-all chain? Do we want a permissionless, and even beyond those questions have much more thorough discussion about it. And we definitely need to have one much more in detail, which is often also not had. And then another thing is the question in the energy system idiosyncrasies. So blockchain was developed for basically fintech, but energy system works in a very different way. And we need to be aware of the system inherent restrictions, especially because we operate on a regulated market and we operate with critical infrastructure. So we can't just trust that everything will go well. We have to be really diligent about what we do. And so we need to think about separating the essential and the non-essential aspects from one another, and to think about the question of trust versus the system responsibility rules. Another thing I would like to consider is that something small is beautiful, and we should include globality where liquidity or flexibility is needed, and especially if we think about like local energy markets, the problem is liquidity usually and flexibility. So maybe it makes sense to have them more globally. But when we don't need that, and often we don't need that, then use a small scale, especially if performance and governance are important to us. And that depends on the use case. We shouldn't just like adopt a global chain and think that that is all there is in the blockchain universe. But if we do choose a lot of small scale little ones, then like an ecosystem, they need to be open and federated and accessible so we can foster the interaction and the synergies. Another thing we should consider is to think about proof instead of logging. Questions: do we need to document everything, or do we just need to prove or check everything? So that in a case where somebody needs to contest something, that they can prove that certain data existed at a certain time, for example. And so that's something that we should think about functionally. And then finally, we're ready for a balanced focus in use cases. There's a lot of organizational, regulatory, economic, and technical barriers. But usually in the blockchain-centered ones, we only talk about the technical barriers, and then projects run against the wall because there's all the other things that are really critical to solving them as well. And so we should think about the essential aspects for use cases. And so we should also, like in that sense, we should go from potentiality discussions to real use cases, because you can't build real use cases if there's organizational, regulatory, and economic barriers as well. And since I'm out of time, I'm just going to put up this summary where you can see the assumptions, the consequences that I've discussed, and I would end this. I'm sorry, it's been very fast, but I had a lot to say. This very intense presentation to open it for questions.
Thank you, Simon. And also I would like to remind everybody that we have also an interactive session on blockchain that will start around 11:20. So those of you who will not be able to discuss blockchain right now, they also have the possibility to discuss that at 11:20. We have one question. Blockchain is energy intensive on data servers, and is that true, or is that another myth?
It is a design decision that has been taken. So yes, it is definitely true, especially with the popular blockchains, especially with proof of work consensus mechanism. That's the one that Bitcoin has, and then Ethereum has had. I mean, they're doing the switch to proof of stake, and it is designed to be very work intense. And if there's a lot of money in it and it's attractive, a lot of people go into it. It's all the work translates to energy, to generated electricity, to power, basically. And so, yes, it is definitely true, because that's how you design them. But what I'm focusing in my talk is that we need to think about what kind of blockchain do we want. And it's a choice whether we want a blockchain technology that is energy intense, that makes it really, really hard for somebody to revoke a decision through just throwing a ton of resources on it, or if we want one where we have some consensus that is by the people that run it, by consortium, by some governance body. And that is comes back to the slide that I had about the governance, where we should think about not just do we want a free for all or a federated or permission or permissionless, but what I meant by going beyond it, to think about, okay, we know what is essential to blockchain is basically have a bunch of blocks that link to one another. So we know that it's very hard to change something, but what does it mean to change something? How do we allow people to change data? How do we allow people to add data, and to think about what are the requirements from the use case? How much resource do we want to allocate to that? How much do we want to allocate to to governance structure or to other things, and then to either build such technology or adapt technology that solves what we really need.
Thank you so much, Simon. As I said, we don't have time for any more questions, I'm afraid, but there's a workshop on blockchain at 11:20, so I'm going to ask all of those who are interested in discussing further to join at 11:30, the breakout on blockchain. And I'm going to now ask Tassos Tissanis from Suite 5 to start with the presentation on data value creation for city stakeholders.
Hello. Hello, everybody. Thank you, Veronica. Can you hear me?
Yes, we can hear you perfectly.
Okay, I will also share my screen.
Yes, perfect.
Just give me a moment. So please let me know if you can see it.
Yet on your left side, there is a button with a screen and an arrow. That's a screen share, so you have to do that.
So you cannot see it yet?
No.
Give me a moment.
It's coming. Perfect. Thank
Okay.
you.
First of all, thank you for the invitation to participate in this workshop. Hope everybody is safe and healthy. I will take you to a slightly alternative direction of how blockchain and peer-to-peer platforms can be utilized, let's say, in the frame of smart cities, in the frame of urban context, and in the frame of data-driven energy applications. So, from an energy perspective, actually, and in our approach, cities can be evidently considered as micrographies of power systems, of energy systems, since they both involve a wide penetration of distributed energy resources. And when we are talking about distributed energy resources, we are talking about mainly renewable energy sources, but I will not take it only on the generation side. We need to consider as the distributed energy resources, smart home devices, appliances, whatever consumes energy, but also other types of devices like storage or electric vehicles that are currently penetrating the power networks. So this increasing growth of DERs, actually, in a decentralization frame, as we can call it, is continuously expanding the edge of the system, the end of the system, and actually the edge of the system, both in terms of controllability, but also in terms of operational complexity. And in our case, actually in cities, since we need to take it down to the urban level, this edge is currently dominated by buildings. And buildings, actually, and we all know it may be a cliche, but in any case, when we are talking about energy optimization in smart cities, we need to consider that buildings are the largest consumer. So, since we are talking about buildings, actually, we need to have in mind that they are progressively transforming into smart buildings, and actually they are associated with generation of a wealth of and vast amounts of data that are mainly coming from building energy management systems, from smart home devices, from smart metering and other information, and from the devices that I mentioned before, the assets that I mentioned before, since buildings are currently integrating, let's say, several forms of energy generation, energy storage, and they are integrating also electromobility. So we have to deal actually with huge data volumes that are coming from an increased number of assets that and are characterized actually by a multi-diverse spatio-temporal resolution. And actually, all these aspects and all these assets actually introduce further uncertainty to whatever control needs to be made, either at an intelligent or at a collective level at the city level. And I will explain even better what I mean. So I will stay first of all to the building level, since such large data sets that are generated, let's say, by buildings can enable, first of all, the enhancement of the intelligence internally within a building through the proper analysis, the proper processing and analysis of the data and the data sets that are produced through big data analytics in order to increase the energy performance of the buildings and provide a variety of services to the building occupants and the building stakeholders. However, how we see and how we touch this issue actually has bring us to the conclusion that the real value of buildings and the data that are generated by buildings is actually hidden on the sharing of this data with the different stakeholders involved in a city context, and actually not in a city context as we conceive it, but actually in the energy data value chain across the city context. Since we are talking about cities that are transforming themselves to integrated ecosystems and to integrated data value chain, so we have realized that actually data generated at the different edges of the city system shall not remain isolated and in a silo format as as they actually are, and as is the reality right now, but are needed to be shared, let's say, with different other stakeholders that may generate value out of this data, since we're talking about an integrated system, and the complexity in operation needs to be resolved out of the analysis of multi-source data sets that are generated at city level. So we have come to a conclusion that in order to enable the holistic optimization at smart city level, we need to promote technologies and promote the concept of data sharing among the different stakeholders. However, when talking about data sharing, there are several concerns, as discussed before by Simon, since it needs to be built on robust principles among data consumers and data producers, addressing critical challenges, actually, that are associated with this approach with regards to data privacy, with data security, with data sensitivity, IPR, licensing, ownership of the data, and leveraging on technologies and concepts around distributed ledger technologies would allow actually the establishment of concrete and robust data contracts among data consumers and data producers, actually, in order to enable the extension of the data reach of the different stakeholders, the exchange of data even in real time, the simultaneous optimization of operations at different sites and different edges of the city system, and actually the creation of a new economy and a new transactional ecosystem around building, around data sets, let's say, and data generated on the building side. So challenges are there, and as we realize, they are numerous. So having this motivation in mind, we have worked both in Sparks project, which is one of the projects that organizes these workshops today, but also in the frame of other projects, namely the Synergy and the Beyond project that are around big data for energy systems, for building systems, and for city systems. And we have prototyped our internal energy data sharing platform, which aims actually on reconceiving traditional forms of data exchange between buildings and parties that are involved in the optimization, let's say, in optimization processes at city level, in order to generate value out of analytics and data sharing performed over the platform, that over a cloud environment actually that we offer. So I will take you back to this figure just to understand later on the complexity that we need to address actually through our platform. However, what I want to go through very quickly is how we approach the issue, let's say, of data sharing. So from a data producer point of view, we provide the opportunity, let's say, to for them to extract the data, actually to ingest their data, and either as batch or as real-time data. And they are offered also the opportunity to increase the value of their data, because we are talking about data streams that may not be complete or may have false entries, let's say, introduced within the structure. So we offer the tools, let's say, in order to increase their quality and safeguard the data prior to making them available, let's say, to data consumers through appropriate data curation mechanisms. And after that, actually, we combine all these data ingestion and data collection mechanisms with appropriate tools in order to safeguard the data in terms of access rights, let's say, that other users may have on this. So they can define the permissions, they define specific prohibitions that they may have, also some pricing models that they need to introduce. And actually, I can give you an example. What they can define is who they can share the data with. So if I am a building and I do not want to share the data with an ESCO, with a specific ESCO, I can define it very quickly through a data access policy management mechanism. On the other hand, I can take it even further. I can decide, let's say, if a specific actor or a specific type of stakeholder cannot access this data, so as to make sure that afterwards, whoever can reach my data, whoever can have access to my data, let's say, is very concretely defined. After going through these initial preparation stages, the platform gives the opportunity to the data producers in order to trade their data and create semi-automated contracts, let's say, with data consumers, in order to be able to share with them not only data, but as we will see in the sequence, the results of analysis, actually data intelligence, as we call it, the results of an analysis, either in the form of reports or in the form of an app that contains the results of the analysis together with an app that contains the algorithm, actually, that has been used in order to create the results of the analysis. So if I take it to the data consumer perspective, they are able actually to access the platform on the other side. Actually, if we can imagine a platform with two ends, the data consumer enters from a different end, expressing their needs and searching the data that are available there. They make specific requests about what they need in order to perform their own analysis and optimize their own operations. And after requesting, let's say, specific data sets or specific data within data sets, they are able to get involved in a contract negotiation phase with the data producers in order to come up together and jointly, let's say, to a concrete agreement and sign a data contract that afterwards will be monitored through a blockchain infrastructure, through a blockchain, through an Ethereum, actually, infrastructure, against conformance with the terms involved in this data contract signed between the different partners. There are several other aspects, actually, that several other services that can be offered to the different data consumers involved in this ecosystem that we described, and have to do with the analysis that they can perform over the data that they acquire from the data producers, with the provision of pre-trained, descriptive, predictive, prescriptive analytics in the forms of personal analytics, when we have to deal with information coming from individual occupants in buildings, but also with industrial analytics that take the analysis level, take the analysis resolution actually at a different level in order to optimize business functions. The results of this analysis can be the input actually for new data sharing approaches and contracts offered by the previous data consumers, which can become data producers and data intelligence producers themselves and share the results of their analysis towards other data consumers. So very quickly, this is the approach that we have followed in order to facilitate, let's say, the creation of an integrated ecosystem and an integrated value chain that can be applied in several contexts. We take it now to the city context by involving buildings in several interactions with the city stakeholders. Actually, and by city stakeholders, I mean the energy stakeholders involved in the city context. And this is actually what, sorry, it's faster than me. What this figure actually in the background depicts, we try to address all these interactions in a trustful and secure way through the utilization of blockchain for facilitated data sharing based on concrete data contracts in order to facilitate this data exchange and these data interactions between the different stakeholders and ensure that everybody is remunerated, let's say, as they should be, based on their requirements and the value that their data should obtain. So,
thank you, Tassos. I'm afraid I will have to stop you here because we're very long into the coffee break already. I'm gonna ask everybody who has questions or would like to discuss again the P2P energy markets and blockchain and the application, that maybe you can join the same breakout room too at 11:20 together with Simon, and there will be more space to discuss this more in parallel. Okay. Thank you very much. I'm going to introduce the 3-minute coffee break very, very shortly, just for those of you who want to stretch their legs a bit from the computers, or those of you who are still in the room that maybe they want to grab a coffee. And we are going to start sharply at 10:05 because the agenda is really packed, and you can see that the discussions are or the presentations are really interesting, and then we don't have time for discussions. So if you can be please back sharply at 10:05, and we will start right there with Natasha from Kimatica. I'm going to be back at 10:05. Thank you. And hello, everybody. I hope that you are still there. That was pretty much the shortest coffee break in the history of coffee breaks. But I can see that most of you are still with us. So I'm going to ask Natasha to please start the presentation and that we can go ahead in the agenda. Thank you so much.
Hello, everyone.
The floor is yours.
Thank you for the introduction. Can you see the presentation?
We can see results from P2P energy donation platform deployment in USA and EU from the project.
Okay. So that is exactly what I will present to you. The peer-to-peer energy donation platform that we have developed for the Positive project and the outcomes of a 2-year implementation of the platform deployed in USA and Europe. So we have developed a state-of-the-art cloud platform for energy donations that helps engage, retain, and cultivate a community of energy donors to provide energy resources to those in need. We help increase the amount of online donations by creating new campaigns or digitizing the existing ones. The platform offers gamification features to further engage users and citizens. The first one is the ambassador feature, where users can create their own personalized campaigns to support existing programs in the platform. For example, they can create birthday campaigns and then invite their friends through social media or email to donate money to their campaign. And the second one is the Save and Donate feature, where users can learn how to save the amount of their donation by following personalized energy saving tips. Sorry. I'm missing the slides here. And the other one is the solar sharing, where users with solar panels can learn about their production and bill savings and select a percentage and share it. Transactions can be performed through credit and debit cards. And the other one is the smart giving feature, where users with smart thermostats can learn how to save the amount of their donation by simply adjusting their heating and cooling needs. And in the next slide, you can see some examples from our partners. The platform was tested with a larger energy retailer in North America called Direct Energy. They used the platform to redesign the existing program called Neighbor to Neighbor. And then it was also tested with the energy provider of Grenoble in France called ZEZ, and the energy retailer in Greece called Iron. They all created social responsibility programs to support low-income residential customers who suffered from energy poverty. And we observed that on average, a 20 euro donation per donor was observed. And in addition, the platform was tested during the environmental disaster from Hurricane Harvey. A dedicated campaign was created within 24 hours of the hurricane to support financially the victims. And what we saw is that in less than 24 hours, the fundraising goal was covered by 200 times. And here you can see some generic findings from the pilots. Our data in regards to the demographics show that most of our donors are women, and the most popular age group is 35 to 44. So this is the top target audience. And in the next slide, you can see that the preferred way to share the campaigns was via email and then direct to one another. And the donations were mostly made through their mobile phone, since the aforementioned age group is mostly using their smartphones as a primary means. And here you can see that we are also developing for positive peer-to-peer energy trading platform, which empowers prosumers with the ability to search energy credits. You can see that the participants will trade direct energy between them. And also that there will be a marketplace where the users' sustainable behaviors are rewarded with tokens. And these tokens can be exchanged, for example, for goods and services offered by local merchants and other entities. And what we have seen so far from our pilot is that the peer-to-peer energy donation platform helped raise enough funds to provide help to low-income families who may suffer from energy poverty. And our vision is that the platform will help the city of Evora provide support to low-income families who cannot afford to pay their bills. And now with the COVID-19 economic impact, we accept that a donation platform will be important for the social bonding of the community. The expected outcome is actually a campaign-driven social responsibility effort of Evora that will provide help to thousands of low-income residentials to pay their energy needs. Thank you, everyone, for your attention. And please let me know if you have any questions.
Thank you very much, Natasha, for the presentation. Is there anyone that would like to either ask a question or post a question into the questions and answers box? Please do not hesitate to do so right now.
I do have a question from it's Miguel. Good morning, everyone.
Hello.
Since this is a solution that implies the link with utilities, do you find it challenging to involve them in this type of solution, or is something that from your experience in the US, they are keen to participate?
The main problem of that is that how utilities will market the message and the solution. But this is the most challenging part for them because we offer the tools and the gamification features to further engage the citizens and the donors. But then they should also promote it in the best way. So I hope this answers your question. But we didn't find it challenging so far.
All right, thank you.
Thank you. We have also a comment from Dorian that is saying that this is great and offers a possible approach to some of the questions that they were raising in their presentation earlier regarding involvement of vulnerable groups. So perhaps, Dorian, you would like to comment on that a bit more?
Yeah, sure. Well, I was thinking also during the blockchain presentations already that where I would have had the question whether this may support also sharing in terms of supporting people and accessing free or granting free access to energy, for example, to people, or whether it only relates to trading in terms of paying for something. And what you're explaining here is really an interesting approach, I think, because we are really thinking about, the EU framework aims at involving vulnerable groups, but we have no answers yet how to do it exactly. So this is a very good example, I think, how this can also be integrated in let's say, technical approaches for sharing. So thanks very much.
Thank you.
Thank you. Do we have any further questions or any other comments or it seems like that is not the case. Okay. So what I'm going to do is that we're going to move then, if there's no further questions, I'm going to move to the next point on the agenda, and I'm going to ask Boris Tisten to start his presentation on the disaggregated market behavior and improving of the system operations. Thank you.
Right, I hope you can hear me. And also see the presentation correctly in a presenter mode. Can you hear me?
We can hear you and we can see that, yes.
Great. Okay, so again, my name is Boris Tisten. I'm a group manager of the AI team in Powell. And for the last year, we've been working with multiple innovation and AI projects, but most importantly with Positive City Exchange, which is EU-funded project that is focusing on creating positive energy districts and energy blocks. And of course, for most of you, that's going to be a familiar concept, but for those who are not aware, we're trying to create within two lighthouse cities, which is Trondheim and Limerick. We're trying to create positive energy districts or blocks, which produce more energy than they consume. And for that, we need to fulfill many things. We need to be able to create a market or a platform for this energy to be traded. We need to come up with incentives in terms of why consumers should want to join this platform. And we're also testing different technologies, like in the context of e-mobility, grid deployed batteries, and different types of AI optimizations and calculations, which I'm going to go into a little bit later. So this is what EU wants, and Powell as a business also is kind of interested in terms of what the customers want to do, and in the end, what the customers care most about is their electricity bill, and now even more increasingly about their personal environmental impact. So we're trying to target the solution so it targets these end customer motivations the most. So that basically means that we set out a mission to solve the energy production and consumption challenges in a decentralized way. What we see is that Powell has been delivering solutions to our customers, which are utilities, which solve it in a very centralized way, and we see that this will not be able to keep doing this with more and more decentralized production, consumption, and the prosumer type of behavior increasing. But also, we don't want to create a solution that just targets the PEPs and positive energy districts in essence, but can be scaled to different levels to kind of target our customer segments, which are utilities, which are over time changing. So, just to briefly describe the problem, let's take it as an example of a positive energy block. We have a bunch of assets. These assets can be various. It can be purely consumption assets, for example, a house with a consumption, electricity consumption. It could be grid batteries. It could be solar power and so on. And then the first problem that we have to answer is, what is the asset energy balance in the future? That means, is the asset going to be net positive or net negative? So we need to answer that question. And when we have that question answered, we need to basically answer a question: how can these assets then trade the energy to get into some balance locally? And then, of course, when you zoom out, the important question is for the utilities: what is the whole area balance going to be?
Boris, hello.
Yeah.
Sorry,
Yeah?
we cannot see your presentation. You're not moving your presentation, so you're sharing your screen, but you're not moving the presentation.
Okay, so let me try to reshare it one more time.
That will be great. Thank you. Perfect. Now it's on.
Is this somewhere else now?
Yes. Thank you.
Okay. So can you see it moving now? or not?
The interruption.
Yeah, it moves. I see it on the screen in the back end in the workshop room. Okay, now it's fine. So to resume. So then for the DSO or for the market operator, the question is a little bit higher level, and that is, how is the area doing now? Is it in a balance? Are we going to is the area stable? Are there any problems, or do we need to do something within the area to satisfy some constraints or the requirements? For example, the grid stability or aggregator type of problems. So when we have this question posed, we need to answer them in some way. And for us, this is a combination of two things. First of all, we need to rely heavily on predictions and calculations locally. That means all of the assets have to be both predicted their production and consumption, and then calculated various things, which I'm going to go into next one. And the second answer is an automated local market. That means it's a local market where people can trade, but they don't trade manually, because of course manual trading in this kind of scale would be infeasible. And the same answers apply to the zoomed out maybe DSO or a grid side answer, where the predictions and calculations happen. Could you mute yourself? Thank you. What is the area? The whole area balance, again, it depends on prediction and calculations, and how can we change the area balance is again done with the market access. So to go into these two boxes individually, predictions and calculation, what that means is that we need to be predicting all consumption and production for at least next 24 to 48 hours. In our case, using AI. This is important. This is important because it's then used in many other necessary steps. It's important for us to know what the asset balance is in the first place, but it's also important for us to know how to plan this asset in the future, and in the end also what type of flexibility was delivered, if there was some flexibility delivered. This is based on the presumption that the latest AI technology and the data-driven technology can actually predict these time series, this data, very accurately, in a way that when we're using live data, the amount of error that we see is usable for all of these points. And then we go into local planning and optimization of the assets. Of course, non-flexible assets, either pure consumption or intermittent production assets, can't be really planned. They can only be predicted or forecasted. But for the assets that can be planned, for example, that have flexible heating, batteries, EVs connected to it, we need to be doing planning. And planning takes in the predicted inputs, for example, local consumption and local solar production, and then tries to plan, for example, added battery level in the optimal way. But what optimal means in our sense is not just locally optimal, but this optimization needs to take into account also the market incentives and the market situation. So this is something that we're developing now, and it's very, very important for the whole platform to tick. And then the third types of calculations are the grid side of calculations. That means for us to be able to tell how the grid is going to be doing in the future, we need to be able to run what we call load flow analysis. And to run load flow analysis, we need to have predictions for every single consumption and production point in that analyzed grid. So yet again, the importance of the data-driven predictions are more and more important. And then the second point was the automated market access. So we then need to be able to connect these assets to a market and trade them automatically using algorithmic trading and algo trading solution and robotic traders. These are then traded by strategies which are based on a type of assets and the experience that we have from trading and so on. So these are set up automatically and then traded automatically. And then all of these trades mean in one market area, and then of course you can do some type of smart aggregation in terms of not trading individual assets, but you can group them based on maybe ownership and so on and so forth. So it simplifies a bit the calculation of the balance. So a little example here. So we have an actor one. Let's call this a house, which has two assets. It has a consumption and production asset. So for that, we have to create prediction and create some type of a plan in terms of how the balance is going to be looking in the future. And using a market participation tool, which is the Powell Algo Trader, the actor can trade put bids into the market. And the same way, other actors are doing the same. So this is basically how we automate the energy trading or flexibility trading between the assets. And now, if we want to, of course, go forward and add the DSO or the grid perspective into play, we will see that there will be some constraints and requirements on this area of the market. So this could be either grid bottlenecks or voltage problems, voltage problems are a big problem in several places in Norway, which is also going to be a place where we're going to be deploying these solutions. So what we have to do is basically run the calculations, detect that this area is going to face either bottleneck or voltage problems, and then be able to influence the area in some direction. And the same way, you can have some requirements, for example, for regulation or any potential aggregation. And in this way, then, the same picture can be used. So we have, example, two actors trading into the market, but in the very same way, a DSO, which does its own prediction and planning in a different aspect, can be accessing the same market, putting for example, buy or sell orders into the market, and then the respective actors with their local planning react to the change situation in the market and change their plans accordingly. So this is how not only energy trading but flexibility trading is done in the same local marketplace. And this central marketplace is a continuous market, so it's very like the intraday electricity markets, which is it's basically open for the times that the spot price is available, because the spot price is then heavily used in the algo trading to set the local prices. So to make sure that we are able to fairly measure and account for the energy being traded, we're using IOTA, a blockless distributed ledger, to basically verify that the traded agreement was kept. So for that, we basically have the IOTA ledger into which we sync all the matched orders from the market and all the metered values, basically. And on top of this, there's an accounting application running, which makes sure that what was agreed on in the market was actually delivered, and then of course takes care of the accounting there. So to sum up, 3 important points to make this platform work, and we'll be deploying this towards the end of the year in Trondheim, and then further in different things in the different places. AI predictions for all the assets, both production and consumption. We have to come up with very smart local optimizations, local in the sense of they are optimizing the assets individually and then meeting in the market. And we need to be doing important grid calculations for the same areas at the same time to be able to verify that the market is actually not breaking the grid, but helping the grid staying stable. And then scaling the automated market access, so it's very low friction to both add new assets into the market and also on a day-to-day trading schedule. This allows us to basically solve these local energy and production and consumption challenges in a very decentralized way. So there's no single central entity that controls it all. So that will be all. Thank you very much.
for the presentation. Is there any questions from the audience or from the speakers? Please don't hesitate to either ask or post your questions into the questions and answers box so that Boris can still answer them. Do we have any questions? Hello? It seems like there are no further questions. So in that case, I'm gonna just ask for the next presentation. Thank you so much, Boris. And if there's any further comments on your presentation, I'm sure that we can also answer them afterwards. And right now I would like to ask Mark van Wees from Amsterdam University to talk about the evaluation of the energy and climate impact of the P2P local energy platforms. Mark?
Okay, thank you very much. Can you hear me and see my presentation?
Yes, indeed.
That's a good start. Well, thank you very much. This presentation will have a bit of a different vibe to the previous one. We take a bit more higher level perspective to P2P platforms. I'm working at the Amsterdam University of Applied Sciences. We are a partner in Atelier. And Atelier is a sibling of Sparks and Positives. All three projects are under the Smart Cities and Communities program of the European Union. And all three projects focus on positive energy districts. We started at the same time, and all three projects include demonstration and pilots of P2P trading platforms. So all part of the same family. Well, our role of the university is internal evaluator, as part of the work package monitoring and evaluation. This is a bit of a mixed blessing. On the one hand, we have the mandate to engage in all highly complex and diverse activities of the project. On the other hand, we will not make ourselves popular because we are going to lean over the shoulder of all our partners and asking them whether it makes sense what they are doing, including those partners which are very enthusiastically working on P2P trading platforms, particularly in Amsterdam. Evaluation, of course, we want to ask at the final, the main question will be asked by other cities from our project, another project. Okay, these peer-to-peer trading platforms, they are interesting, but do they make sense for my city? So this is the basic question we need to answer at the end of our project over a couple of years. Positive energy districts, for those of you that are not very familiar with that, it is an intermediate step within, say, the climate neutral homes and the final target, climate neutral or energy positive cities, where you look at a district level, a neighborhood, either regionally demarcated or virtually designed, where you aim to have a higher production within the PET area through high intensity of renewable energy, high efficiency, and flexibility to come up with an energy positivity. And in addition, the PETs should also serve economic and social objectives. This is the area of Amsterdam, where we are going to implement this PET. This is north of Amsterdam, Buikslooterdam, and there will be a mix of greenfield developments as well as incorporation of existing building blocks. We take in this presentation the energy perspective. PET is in principle an integrated energy system. So the four pillars are energy efficiency, renewable energy integration of electric mobility, and the area of most concern to us now is energy system flexibility to allow peak shaving, optimization of demand, balancing energy demand and demand, supply to be able to integrate more, and particularly more renewable energy. So what we see if we look at the current development of PET demonstrations is that, of course, that in all PETs, smart grids are being used, energy management systems are in place, but in many places, so which is crucial to any pet. But in addition, like in Amsterdam, you see that many of these pets projects are also going to experiment and pilot trading platforms. But it is a very early stage. So what we would like to know is, as an evaluator, at the end, what does P2P trading locally contribute to the energy and climate objectives of a pet? In what way, and how is that influenced by the context in which these pets are being implemented? This is an open question, and to that purpose, we have started by understanding the system or the theory of change or the logical framework, how these P2P platforms at the end could lead to the impact on energy and energy efficiency, which are the overall objectives of a pet. And this is a mapping exercise, a theory of change, which we have started. This comprises not only energy volume trading, which is the focus of this workshop, but also energy flexibility trading, which was also mentioned in the previous presentation, and to see what it would be the cause and effect to come up with the final impact on the right-hand side on energy efficient renewable energy, and what mechanisms, what causal effects could then be influenced by the project interventions. This is early days, but we think this understanding of this system is essential to be able to identify the critical areas for evaluation. Maybe of the most interesting to go into more detail is the impact of the energy volume trading on the rest share in positive energy districts. The idea is to make it as high as possible, potentially 100%. How could trading contribute to that? And by the way, I would recommend, if this topic is of interest, to read the reports of the City Exchange projects, which are also used as a basis of this presentation. Well, you can see my cursor. You start, of course, with an energy system in place and a local trading platform in place. To this, that you can apply blockchain, and you need to consider regulation. The two topics to be addressed that are addressed now, but obviously that should lead to a certain trading volume by active participation, and that depends, of course, on the trading interest of the citizens or the participants. And that, of course, can be influenced by your approach to citizens engagement. You need to have people actively trading in whatever form. And the incentives is the tariff system. Obviously, then that could be important that people express an interest for locally produced renewable energy sources. There needs to be a willingness to pay a bit of extra money for locally produced renewable energy sources. And that also could be influenced by citizen engagement. But that's not the end of the story. Then, of course, what this results in additional revenue for your best, but that is only can result in additional renewable energy production if you have a business case or an additional local capacity for us to be able to increase that local share of renewable energy. So what we see, it already helps me, this system, and hopefully you as well, to locate the topics that have been discussed so far. And if you look at what Simon discussed on blockchain and the different design parameters and choices you can make, that fits nicely into this area of this theory of change. The regulations have been discussed. But what I notice in general already, there's most of attention now is on the left-hand side. But at the end, we also need to understand how the right-hand side works. Can these financial incentives that are a result of peer-to-peer trading and the preference for renewable energy actually lead in practice to additional renewable energy production within a positive energy district? So as a final slide, actually, this is an open invitation. We see now many pilots on P2P trading platform starting to be implemented, and obviously this can only be a source for a validated conclusion if we use a portfolio approach and learn from all these pilots. The design parameters are so wide, the contexts are so different that we need to work together to be able to draw overall conclusions, which are valid for many other cities. To that purpose, we are working now together with other projects to come to some sort of harmonization on how we are going to evaluate the impact of the peer-to-peer trading platforms on very practically harmonize the KPIs we are using, both for the assessment of the implementation modalities and the different impact areas. Then, obviously, through the implementation of our projects, we will work together, exchange interim experience with this, and this workshop is a starting point. And then at a certain stage, we are going to monitor the impact of our pilots and come together and see what common lessons can be learned. So this is an open invitation to everybody that deals with the same mission to come together and try if we can make as much out of our work as possible to be able at the end to be able to reply to the question of a city: is this something for our city as well? Thank you very much.
Very much, Mark. And maybe you can share also afterwards your contact details if you would like to then discuss with other participants or speakers more in detail. We do have a question from Lucas Porto. Will citizens need to be trained to achieve efficient P2P trading?
Well, that is one of the key questions. I don't know yet. We hope to see in all these different pilots different approaches to engage citizens. In principle, in principle, we know that we need to keep it simple. The challenge will be now because the existing pilots and existing script often target a limited section of the population. In Amsterdam, we have some going, and these are really, let me say, high level, very climate aware people with high income who are engaging in this, and we need to make a shift that we make this attractive to a broader section of the population. And in general, we should keep it simple. So I doubt whether you want to introduce a system where citizens, inhabitants of a PAD really need to be trained, because that may be a huge barrier. But that is something that we hope in the different pilots, the different mechanisms, the different interactions will be tested and piloted, and we can come to a conclusion which works best. But it is a question that cannot be answered yet. We need to find it out.
We have also another question from Rudy Ruth. If you could please comment on the amount of energy savings, perhaps in percentages, in grid losses that would be possible through local RESUs.
Very good question. That is a very difficult analytical question, because it's also very context specific. In some cases it will be zero, and in some cases it will be high, and that's a research topic we want to pick up. So I cannot at this stage mention any. But it is in any case, it is not obvious, and it will not also always be the case that peak shaving will lead to energy efficiency through grid losses. So that needs to be assessed in more detail.
Okay, thank you, Mark. We have just one more comment. If you can please recommend reading about the P2P volume trading that you have mentioned from the project City Exchange. But maybe what we can do is that all the resources and all the further reading that all the speakers are recommending throughout their presentation, we can also then share that afterwards, because we will be sharing the recording of the workshop and perhaps also the presentations that we can. So we can also share further learning. If you want to just comment on that shortly, Mark, or
yeah, just Google City Exchange, and they have already an excellent list of a knowledge center, and then you find the reports.
Okay. Well,
very recommended, because it's a very good overview.
Yeah. And we have one more question. What is your impression of tariffs as an incentive? At least for electricity generation costs, they will hardly be lower than electricity from the grid. For example, local tariffs reducing taxes, surcharges, etc., may be more important, as we were showing. Or do you expect participants to be willing to pay more for local energy?
Well, that's a crucial evaluation area. What we witness is that when I think about the broader target group, not the very sensitive, aware people, but those, say, by the common average citizens, we see that the price elasticity of energy tariffs and energy costs is not very high. One example is that every year we have a lot of offers from energy companies that say we are the cheapest, and even though the differences can add up to a couple of €100 a year, which is a significant amount, very few people switch. So that will, and we saw another observation is that also the number of people that are willing to, well, although green energy is not more expensive, but I expect also for tariffs within local trading that the price of electricity will be low. How much? That is to be investigated. So that is, I maybe would be one in say one of the most critical barriers that we need to evaluate, and that will influence the real impact of this trading on the energy objectives.
Okay, thank you so much, Mark. If there are no further questions, I'm going to then thank you for your presentation and for all of your insights, and we're going to move to the next presentation. I'm going to ask Beryl Alpagut to talk about citizens in future PDs, PENs, and PRs. Beryl?
Yeah, hello.
The floor is yours.
Yeah, I'm sharing my screen, just a minute. See my screen now?
The three dots, I believe, and that's where the share screen is. Yep, perfect. Thank you. We can see that now. Perfect.
Okay, perfect. So hello, everyone. This is Beryl from Demir Enerji, and we are a Istanbul-based consultancy company, and we are working on climate change strategies, renewable energy, energy efficiency, and mostly smart cities and energy management and energy planning in cities as well. We are running 9 Horizon 2020 projects, and of which 5 of them are smart cities and communities calls. And Making City is our latest smart city project concerning the design and implementation of positive energy districts in lighthouse cities. And we are leading the PET methodology development and rectification activities for this project. And most of my colleagues already mentioned about the traditional and the emerging energy systems, but I would like to also give a slight introduction to the floor. And according to the traditional systems that we are running now, the electricity is generated by big power plants and transmitted to the city, and distributed to the consumers in the city, and to the households, companies, let's say, and other service providers. And it really shows a linear and vertical and a top-down approach. But as you know, the power demands are rising, and the availability and the reliability of the is becoming the primary concerns in energy systems. And reliable and cost-efficient electricity supply is very, very important at this case. And the distributed energy resources are providing the renewable energy and the storage that is added to the grid now. So it really brings new operational challenges, but also provides business opportunities and revenue streams, new revenue streams as well. As most of you know, according to the Trias Energetica model, it is acting as a guide for the energy sustainability in urban planning and design. And it has 3 pillars. And the first pillar is the minimizing the energy consumption by reducing the energy demands in design of the buildings, in the transportation systems, let's say. And to fulfill these demands, it emphasizes the use of energy, sustainable energy generation, for example, the renewable energy. And after that, if also needed, if still needed, use of fossil fuels, but as efficiently as possible. While we are going towards these positive energy districts for sustainable urbanization, the new trend is about the energy flexibility. It really enables the communication and trade between the peers, and its aim is to reach to the localized market, let's say, and the prosumers, that they can be both individuals or like households, or even more like communities, organizations, and they are on stage now for the local renewable energy production. And they are just really just not producing and consuming, but also acting as proactive actors for resilience and balancing this regional and local energy system. So the citizen control and the local autonomy is being increased in the new concept. The studies show that by 2050, approximately 45% of the European households will be producing their own renewable energy. And it's expected that 1/3 of it will be provided by the renewable energy cooperatives as well. So there's a huge opportunity here for the regional economic development. And so, the locally owned renewable energy projects, they really deliver much more value when compared to the project owned by private companies that are outside the area, that are outsiders. And the energy debate until now, the problems and solutions of it, mostly dominated by the technological and economic issues, as we all explained in the whole workshop today. But the social questions are also important, because they are regarding the change to the energy transition in socio-technological systems. The social part is mostly sidelined, let's say, but the cooperation between the citizen and the local government should be the key to provide the socio-technological transitions. And in the this new concept, new and innovative roles of citizens are also arising. Like within the traditional systems, the citizens were in production, but in some production, let's say, but without sharing mechanisms. So they were doing this system for their own benefits, and they were acting as an investor for themselves. But with the flexibility mechanisms, the citizen is gaining more roles, like a trader, energy trader, or citizen as a prosumer as well. The citizen can participate as an individual, but would have more power and pressure on decision-making processes if it is a member of an organization, a cooperative, or any other association. So citizen as an organization member has more power when compared to the individual ones. And also citizens' knowledge now is getting importance, because it develops effective and democracy building through this participation. Citizens use know-how, participate science by their own platforms, and they are by the help of these platforms, they are planning and designing, co-planning and co-designing the cities. So citizen is now as a participator designer, and also a citizen as a scientist as well. So before taking all of the questions from your side. I would like also ask questions to the floor, and maybe we can also discuss these in the interactive session later as well. So after this point, what are the social impacts of energy transition, not just for individuals, because we're always talking about the citizen as an individual, but what about for community as a whole? And how do you want to regulate the system? Like, will the community really participate as a planner? And will also participate to the co-creation processes at policy level? And how do we want to regulate this system? And also, what are the benefits of this sharing, mostly social benefits of this sharing economy? As you know, this sharing economy is the model for the peer-to-peer based activity of acquiring and sharing access to energy. But that is often facilitated by a platform, a community-based platform, and also an expert marketer. But what tomorrow if there is no, when there is no expert marketer, but the platform will act between just the citizens? And what serves the public good best, and what doesn't in this case? So after these questions, we may say that the potential social implications to the questions should be more value-driven, not just profit-driven. And the core values should be related to social causes, the ecological causes, and of course local economy and the trust as well. So the importance for the lifestyles and the cultural change in communities and the local employment opportunities, the increased social trust between peers, and the increased community attachment and belonging, like sense of place is getting important as well. And of course also increased awareness causing less energy consumption by participation through the participation of everybody in the system, and the increased revenues for local governments as well. So we should consider this ecological justice is highly hyperlinked with the social innovations in this system. So new questions are arising as a conclusion, let's say. So after this point, do we really foresee the role of the peer-to-peer in the energy transition as one of increasing citizen control over the energy system? At the beginning, I was mentioning about the citizen control is arising, but is it really, do we really foresee it? And we are always talking about the supply and the demand side and the scenarios regarding the transition. But what about the design for fairness, equal access, and broad-based control on the system now? So thank you very much for the presentation. And I would like to take any questions if possible.
Thank you very much, Beryl. We do have time for questions or comments. So please, those of you who would like to ask something, now is your chance. Either post the question into the question box or ask directly, please.
I would have a comment, if I may.
Yes, please.
Dorian from the meeting room. Well, everything you're saying fits very well also with what we were presenting and the questions we were raising. So how to involve, in our case, vulnerable people, for example. And just to add, the EU frameworks on energy communities, as we mentioned, do highlight all of these aspects in terms of energy communities being independent and so on, and addressing vulnerable people. A prime question really is how to feed this with in the actual implementation. So the detailed rules need to be set on national level and on community level, and so all the questions you're raising here, I think, are very important and should be dealt with also in the legal frameworks and in implementation, of course.
Yeah.
Thank you.
Yeah, so it's not a question, but it's also supporting the ideas that we have mentioned. Yeah, the most important thing is it's also in Europe, we have very different social, cultural contexts in this context. So in the EU context, so it really plays a key role for how to arrange the differences between these contexts and how to regulate the system as locally in different environments. Yeah. Any other questions?
Yes, this is Mark. I've got one question here. We talk about facilitating and empowering citizens in the energy markets, giving them more control. But what I'm referring to the remarks I made, what do we know about what citizens want? Do they really want, especially if you move towards addressing, say, the more enthusiastic ones to the more average citizens? What do we know already about their motivation and their willingness to do this? And because they are the client. So how much evidence do we already have that if you offer these opportunities of higher engagement, that they will be adopted?
Yeah, Mark, it's a very good question. I think we don't have so much evidence, but so in these projects, in these post-energy district projects, now we are working on, we are always trying to find these answers by getting the citizen in the core of the transition, but not just as an individual, but also if it is a group of a community, it's more clear. And it will show, I'm sure, more evidence that's what they want and how will they be included in the system. So it's a research that is still conducting in this project, I think.
Okay, thank you.
Great, thank you, Mark, and thank you, Bero, for the comments and answers. Does anybody else have any further questions or any comments that you would like to raise? If that's a no, then I would like to thank Beryl and invite the colleagues from Leipzig for the final presentation before we go into a bit more kind of interactive modes of the workshop. So I'm going to ask David Bausch and Sebastian Böhm from Leipzig to talk about how the city of Leipzig and Leipziger Stadtwerke are working together for the energy transition. And the floor is yours, David and Sebastian. Hello? Yep, perfect. I can see Sebastian already. Perfect. Can we hear you? We don't hear you, Sebastian.
Okay, sorry, I had a double muting.
Okay, perfect. Now it's better.
Yeah. Let me see if David is already here. No, okay. So, shall we start? Okay, so I just start and try to explain what the City of Leipzig would like to do. So the City of Leipzig and Stadtwerke Leipzig are working together in the Sparks project, and our aim is to get a green revolution for the City of Leipzig and to have an energy transition for our city and the region of Leipzig. And we would like to show how we work together. So for the City of Leipzig, they are engaged for several years in the energy transition and to reduce CO2 emissions. So here we can see what they were doing since 1993. They try to improve the climate. And last year there was the proclamation of a climate emergency